Welcome to DP Tutorials by Don Jarva. Now I will be explaining and highlighting one important discussion and derivation and interaction on Coulombs Law of Electrostatics. Coulombs Law is a very important law in electrostatics which discusses about the force of interaction between charges at rest. And this Coulombs law of electrostatics is very peculiar in the sense that it explains about this force of interaction. It might be attractive or repulsive between 2-point charges located in space. Now, when we look at the working formula of Coulombs law of electrostatics, it is given by this formula of F equals 1 by 4 pi epsilon naught Q1 Q2 divided by R square. If we don't take into consideration this R21 cap, which themselves are unit vectors, or R12 cap, that is the scalar form. But when we express in vector form, these forces are represented by this vector notation, which is denoted by F12 bar or F21 bar. Now, when we explain the details of these forces of interaction, which we have know that F12 will be the force on charge Q1 due to Q2. Now, when you look at this diagram, you will observe it is evident that Q1 and Q2 are 2-point charges in space, and these Q1 and Q2 are at a distance of R1, or we define R1 as the position vector. This R1, these R1 are nothing but and R2, R1 and R2, we define these as position vectors, PVs. Now, when you look from this diagram, Q1 and Q2 are point charges. R12 is nothing but the position vector. R12 is the position vector directed from Q1 to Q2, and R21 cap is the unit vector directing from Q2 to Q1. Now, there are forces. Suppose if we take why this force F1 and F2 are opposite with respect to each other. In this case, these we will consider that these charges Q1 and Q2 are light charges. When these are light charges, that means the F1, the forces F1 and F2 will be oppositely directed, which it has been clearly indicated over here. Whereas, if it is unlike charges, that means there will be attraction. That is the uniqueness of these forces F12 and F21, which are being shown here. That F1, F21 and F12 are oppositely directed. What is the reason? The main reason is this one. This is the main reason. This is the most important reason that why F12 and F21 are oppositely directed. Now when you look from this diagram, what will the forces F12 and F21? Forces F12 will be force on Q1 due to Q2, and force F21 will be force on charge Q2 due to Q1. Now with respect to F21, the direction will be governed by this R12. Let me repeat. With respect to F21, the direction of this force will be represented by this PV, by this unit vector R12. And with respect to F12, this is F12, the unit vector will be this R21 cap. Now, when you look at this equation 1, when you look at equation 1, the force F12 is given by this expression, but the direction is R21 cap. F12 R21 cap. F12 R21 cap. And F21 is R12 cap. F21 R21 cap. So, but it is very evident that these directions R12 and R21 R1 are oppositely directed. So when they are oppositely directed, if you substitute on this equation 1, you will find out that this equation reduces into another relation. So now let us write, that means this F12, this force F12 will be equal to this force F12 will be equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Now, since R12 is equal to minus of R21, why we put this negative sign? Because they are oppositely directed. So in place of R21, in place of this R21 cap, we will substitute by minus R12 cap. Just the opposite. You can correlate from there. Minus R12 cap with the bracket. Now, when you reduce this equation, we'll take this negative sign outside, and we will have this expression 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now, this divided by R square, and the unit vector will be R12 cap. Now, what is this term inside the bracket? This term inside the bracket is nothing but RHS of equation 2, which is nothing but F21. So, finally, we will get a relation. Then this is equal to negative of F21, which clearly indicates, and we have proof over here, that F12 bar, it is equal to minus of F12 bar. This discussion or this result indicates that forces for light charges, it might be, when I say light charges, it means that Q1 might be positive or Q2 might be positive. Another case, it might be Q1 is negative and Q2 is also negative. That is the meaning of light charges. So F12 and F21 for light charges will be force in this case will be repulsive. Force in this case will be 1. Force in this case, let me write here. Force in this case will be repulsive. And this condition is very important in physics in the chapter of electrostatics. It gives us that this electrostatic force is also known as the central force. This relation is very, very important, in which it indicates that The force of electrostatics is also known as what? Also known as a central force. Central force. Central force. So what do you mean by central force? A central force is nothing is that type of force in which it acts along the line joining the two charges. When I say a central force, that means it is a type of force in which it acts along the line joining the two charges. It acts along the line joining the charges. Joining the charges. So that is the important characteristics of your Ohm's law in vector form. So this is the important criteria of Coulomb's law in vector form. So for the next module, we will explain in the next interaction. Thank you.